So I think, how is the role of the water system or operations for the agents? Are we going to see that the plants are going to be handled by many agents, digital agents, plus one conductor? I mean, or what's the role of the agents in the world of water?
So this is a quite interesting question because at first AI was more analyzing things, and now we are in the agent era where AI is not just analyzing and giving you feedback, but taking actions. Okay, so that's the future. Also because it saves a lot of time and really avoids human interaction where it's not needed. So how future systems will work? Let's say you still will have the SCADA system; it will be there, okay. But then you will have AI running like an interface, getting this data, evaluating things, and where you give AI freedom, they will take actions. Okay, between limits, so you can say, well, the chemical dosage you can vary from X to epsilon, okay? If you think that is needed to change the dosage in these limits, you can do it. Okay, so you you still have control. You won't give total freedom to any AI agent to do everything, okay? But you will choose where your AI agent will work. And the other thing that will happen, and we are talking not about agents, but also, well, it's a kind of agent, but these models where you interact with the system. So that also will happen. So an operator will start their shift and they will ask the SCADA system, which are the main problems that are happening in the plant now. If I am able to look at only 2 areas today in my morning, where I should go and look. So, and also make simulations. So, for example, someone calls you and say that the flow will go higher in 10%, or they need 10% more water tomorrow. Okay, you can ask, I need to produce 10% more water tomorrow. Which train or what actions I should do to make this in a best economical way? Okay, so the model will interact with you like an agent, maybe sometimes taking actions where you allow them to do it, but sometimes just giving you more insights and more feedback and giving you, or for example, it's happening. You have some programs that can allow you to identify if a fouling is a biofouling or a chemical scaling, something like that. But you see the pressure going up. Okay, you can ask why this is happening, and sometimes the model will say, well, I'm not really sure, but I can say to you that 70% is biofouling, 30% is scaling, something like that. Okay, so you start investigating the biofouling because the system gave you a north. Okay, so this kind of stuff is not the future; it's already happening. And I clearly can see that that will enhance efficiency, and that will make the life of any operator easier. Okay. And if I would be an operator or anybody that wants to start in the AI world, I will start from that point. So not really learning about programming. This is not more necessary at this moment. Okay. You should have some knowledge related to all aspects of it, from data, from sensoring. You should have information about how data is storage. You can store a value at each second, each 10 seconds. You can store a mean value for each hour. So all these decisions, you need to understand what's happening. This is data science, okay? But then you should also learn about the algorithms and how to interact about it. So what we were talking in the beginning, and from conversations that we had in some congresses where we knew each other and we had been talking about this for some time, is that you can't find all this information in any place. It's like you need to look for it in many different areas and trying to collect all these information to make a full picture and to have really knowledge to make a good use of AI in the water world.
Right.
That's the point.